So welcome back to another video on multiplying whole numbers by numbers with decimal places. And this video will actually be looking at the decimal place method, put the DP edition. Here we look at counting decimal places and multiplying numbers that way. So what is a decimal place? Let's have a look at this number here, 307.294. Quite simply, anything that's after this decimal point tells us a decimal place. So how many numbers are after the decimal point? 1, 2, 3. So this number has 3 decimal places. Well, what about if I went ahead and did this? Now this number has not 3 but 2 decimal places. And what about if I went ahead and did this? This number has 1 decimal place. What about something like this? Because of all these zeros, does it mean that these aren't decimal places? No, we've got this 6 here at the end. So that means that 1, 2, 3, 4. There are 4 decimal places here. So let's look a little bit briefly at place value. What we can see here is that 3 is in the hundredths column, so it means this has a value of 300. The tens column is actually empty, but we don't just leave it empty and push our 3 and 7 together. We put a 0 there to represent that as a placeholder. Our 7 is in the units column, so there's just 7 of them. Here in the tenths column, there is a 2, so that means the value is 0.2. And the reason it's called the tenths column is we'd need 10 of these to give us the value of 2. Over here, we have the hundredths column, and we would need 9 of these. Sorry, we would need 100 of these 0.09 numbers to give us 9. And also in the thousandths column, we have 0.004. And this means you would need 1,000 of these numbers to give us the value of 4. So if you've seen the video on moving the decimal, you would realize, or if you know how to move the decimal, you would realize that here, to make this a whole number, we like using whole numbers because we're familiar with them. If we want to make this whole number, we'd need to times by 1,000. And why is that? Because 1,000 has 1, 2, 3 zeros in it. And our number here has 1, 2, 3 decimal places. So once we do 307.294 times 1,000, we're going to make our number bigger, so we're going to move on with decimal to the right by 3 places. 1, 2, 3. Which leaves us with an answer of 307,294. Ultimately, what we could also go ahead and do is make a note that our number here has 3 decimal places. We can say originally it has 3 decimal places, and we can just go ahead and wipe that decimal place away, and given there's 3 digits here, we'd replace it with a comma. And as long as we've got this little note here on the side, we should be fine. When we come back to it, we can say, oh, this number here needs 3 decimal places. 1, 2, 3, right here, that's where I'll put the decimal. If originally we only had, say for example, 2 decimal places on this number, we'd say, oh, well, we need to give this number 2 decimal places. 1, 2, they can be our decimal places. Here's the decimal. So here, let's look at some of these questions. 12 times 6.5. Well, if we make a note to say it's got 1 dp, we can just write 12 times 65. Same goes for this question here. 4 times 3.8. If we write 1 dp, we can change it to 4 times 38. And here, 6 times 4.9 becomes 6 times 49, all with 1 dp. I'm a big fan of writing this notation down. You'll see it in one of my other videos where we're timesing decimal numbers. You've got decimals in both of the numbers and they go up to 2, 3, 4 places. This notation will help you with that. So it's a good practice to get into. As many of you know, I'm a big fan of partitioning, so I would do this by partitioning. 10 times 65, 650. 2 times 65, 130. That would give me an answer of 780. Okay, now in this answer, 780, the thing I need to be mindful of is that I need to give it one decimal place. So here, I've got 1 dp, so I need to give this back one decimal place, and therefore my answer to the original question is 78. I'm not going to write 0.0 because we don't write 0.0. We could write it on every single number and we just would be wasting time. Here, 4 times 30 would give me 120. 4 times 8 would give me 32. Altogether, 152. So when I'm writing my answer in here, I would need to give it one decimal place, and that decimal place, that decimal point would go between the 5 and the 2, like that. And if you think about it, 4 times 4 is 16. This is a little bit under 4. So this answer is a little bit under 16. That works fantastically. Here, for 6 times 49, I'd use a compensation method, and I would turn that into 50. I'd borrow 1, which means I'd have to give 1 back 6 times afterwards. So 6 times 50 gives me 300. And then I would have to take away 6 from that, which means my answer would be 294. Okay, so in writing that answer over here, 294, I know I need to give it one decimal place. So this is 1 here, put my decimal there. It reads 29.4. And again, 6 times 5 is 30. This is very, very close to 30, just underneath. So it's likely my answer is correct. Great, let's have a look at some exercises for you to do. Okay, so we have some exercise questions here. These are all everything we've been doing with the example. So I'd like you to go ahead and have a go at 1 to 5. 6 to 10 are a little bit different because we're moving into 2 decimal place territory and even 3 decimal place territory. The method we're doing is not changing at all, but I will come back with an example before I present these answers. So if these make you feel a little bit unnervy, go ahead and just do 1 to 5, and I'll be back with the answers in 3, 2, 1. Are you ready for some answers? Okay, here we go. We have 21.3, 16.5, 19.6, 50. Hey guys, just me from the future here to point out that 12, not 11, but 12 times 4.7 is 56.4. 51.7, 113.4. I will stick around at the end of the video to go through how I did these calculations, but I'm sure you have your own methods. Hopefully you got the right answer. Let's have a look at how to do some of these. So I'm borrowing a little bit from our previous questions, but here we have 3 times 7.15. We notice this has 2 decimal places, but what we can do is we can go ahead and rewrite it. I'm going to write it under here as 3 times 715. Here, this also has 2 decimal places. I can write this, just write it anywhere really, it's just a mental note. 2 times 475. Now, we'll have our own methods for doing these calculations. You might prefer column, you might prefer partitioning. I personally am a big fan of partitioning. 3 times 700 is going to give me 2,100, and 3 times 15 is going to give me 45. Let's put this all together. There we go. We get 2,145. But I know this number actually should have 2 decimal places. So 1, 2, here, that's where my decimal point is going to go. Just like down here, what I would actually do is say, oh, this is 25 away from 500. So let's do 2 times 500 to give me 1,000. take away double the difference, which is 25 doubled is 50. And there we go, 950. Voila, there is my answer, 950. So when I am answering this question here, 4.75 is 100 times smaller than this. But what I'm going to do is work by my DPs and say, right, 950. This question needs 2 decimal places, 1, 2. Here's my decimal. And in my final answer, I don't have to have this in 0 here. I don't have to include it. It could just be 9.5. Hopefully that makes you a little bit more confident to have a go at questions 6 to 10. So I recommend you pause it. I'll be back with some answers in 3, 2, 1. Hope we're ready for some answers. Okay, so our first one, 13.5. Second one, 18.09. 32.96. Next one is 22.2. And our last question is 0.625. Hopefully you guys have learned something, and I will do some more on how to do these calculations for those of you that want to learn more about your how to multiply different numbers. But otherwise, we're done with the DP method here. As always, I appreciate any comments left on the video, likes and subscribe. If you want to give me some more information about the problems you're specifically dealing with, maybe specific calculations you've got trouble with, a method that you want help with, leave all of that in the comments, please. Thank you. So for those of you that want to have a look at the multiplication techniques that I've used, let's start off with partitioning. For 3 times 71, I would have done 3 times 70 is 210. 3 times 1 is 3, and therefore we get 213. Here, this one is quite straightforward as well. We would do 150 for 30 times 5. And then we would do 5 times 3, which is 15, and that will give us 165. The next one is a bit more of an interesting technique. 7 times 28. I've done a couple of videos on multiplication, and one thing that I really like doing actually is breaking it down into its factors. So I know that 28 is 7 times 4. So I would change this to 7 times 7 times 4, which I can then write as 49 times 4. Personally, for me, this is quite an easy calculation because I can use compensation. It's 1 away from 50. So 50 times 4 is going to be 200. And then I just minus 4 off that because I borrowed 4 sets of 1, which is going to leave me 196. So I originally made a mistake with this question, 12 times 47. What I ended up doing was 11 times 47, so make sure you don't make that mistake. You want to do 10 lots 47, 470, and then 2, not 1, 2 lots of 47, which is going to be 94. There we go. And we bring everything down into the columns, carry the 1. So we get 564. Next one, let's have a look at this. I also went ahead and broke this down. 18 times 63 became 2 times 9 times 9 times 7. Reason being is one of the first things I saw was that this is in the 9 times table and this is in the 9 times table. I quite like to do this, as you can see here, with 7 times 7. I like to break down in factors, especially when there is squared numbers involved. So 9 times 9 is 81. Let's double that, 162. Now I switch to partitioning. So 7 times 100, 700. 7 times 60, 420. 7 times 2, 14. 1,134. Moving on to 6 times 2.25. I just decided to do a bit of partitioning here. 6 times 2 is going to give me
12, and then and it was 6 times 0.25, which I think most people know is equal to a quarter. Okay, so what I can actually do is something called doubling and halving, and that's a technique I've used shown in another video as well. We half 3, it's half 6, so we get 3, but we double this, so we get 0.5. Okay, and that makes life easier because 3 lots of a half is 1.5. 13.5. Here I'm going to be a little bit lazy. I'm not going to write out the formal method, because we can partition and see it happening right in front of us and keep the numbers in the same columns. 3 times 6 is going to be 18. 3 times 3 is going to be 9. It doesn't move column. It's still in the hundredths column. There we go. We don't need to write anything extra for that one. And in fact, this is exactly the same as well. 8 times 4.12. So 8 times 12 is going to be 96. Okay, which means that it stays here. It doesn't carry over to the whole numbers column, the units column. So let's just do 8 times 4, that's 32. And then we're going to do 0.12, which 8 times 0.12 is going to be 96. Okay, here, this is quite easy because we've got the same number. So 4 times 5 is 20, and I'm showing you we can work it from different sides. We don't have to start with the hundreds column, we can start with the units column because we're going to add 20, and we just move along a column, and then we just move along a column. So 4 times 50 is 200, 4 times 500 is 2000. Add this all up. Perfect. And there we go. But our answer has 2 decimal places. It was originally 5.55. So we go ahead and put 2 decimal places in there. Okay, so what calculation method do I use for this last one? I'm going to be honest, I cheated. Straight up, just know these ones. I don't know if it's cheating or just knowing your powers of 5. So 5 squared is going to be 25. If we do 25 times 5, we get 5 cubed. That's 125. And if we times 125 by 5, we get 5 to the power of 4, which is 625. Which is also known as 5 squared times 5 squared. So 25 times 25 will be 625 too. And then we just need to put our decimal in the right place. So it's 0.625. That's all, guys. Hopefully you have managed to enjoy using these methods. Again, let me know which ones you prefer, if you're getting flexibility with each different one. I find the best thing to do is to learn how to do each one and then use them depending on the numbers. As you can see, I've used an array of different methods here, and it's just beneficial for me. Good luck.